Hi everyone, I'm Furino, and I'm a customer reliability engineer at Noble 9, and today I'll be talking about the life of SLOs, more particularly around how the service level objective development lifecycle can be applied to help you not only discover and design your reliability targets, but how you manage them through a complete lifecycle. What I'm sharing with you today is the output of a body of works and ideas from contributors spanning several industries. Here, you can see a high-level overview of the SLODLC. If you'd like to know more about the theory of the SLODLC and its various phases, please check out Kip Merker's talk linked in the video description. Today, I'll be covering 4 case studies. One is fictional, but the remaining 3 are real-world examples that I personally have encountered and have been influential to the development of the SLODLC. Let's get into it. The first case study we have is Wiener Shirt-zel. Wiener Shirt-zel is a fictional e-commerce site from Alex Hidalgo's Implementing Service Level Objectives book. They sell pet clothing, and recently had an outage that contributed to poor user experience. Let's dive in and discover how SLOs can help them become more reliable. The first step of the discovery phase is to identify the user journey. As a user, I want to buy cute clothes for my pets. Okay, this is pretty reasonable. What expectations do we have around that user journey? It should work like a normal e-commerce website, with quick and easy checkout. It's also pretty reasonable. What dependencies exist? We're dependent upon our hosting provider and our card processor. Alright, this is pretty standard for e-commerce. What have been some observed system behaviors? We had abnormal site usage, which led to an outage in our catalog service on January 14th, International Dress Your Pet Day. Now it's starting to make more sense. So, one of the first things I like to do when designing SLOs is to get the lay of the land and see a service architecture diagram so you know what you're working with. We can see they have a CDN, load balancer, web app, several microservices, reporting, nothing too fancy. Let's try to relate this diagram back to what we learned during discovery. When doing so, it's evident that we need to look at the catalog service. Generally speaking, the first SLOs I recommend instrumenting are for the availability of a service. If catalog isn't up, efforts to measure it or, for that matter, do anything else are futile, right? Here, we can see that they've chosen to measure HTTP status codes at the load balancer. Okay, this is a good start. Let's continue to get closer to the issue that contributed to that outage. During the outage, we had increased time to write to our catalog DB. Great. We need to measure the end-to-end latency here. Let's map the end-to-end workflow for that path. Going back to the service architecture diagram, let's start designing SLOs with the first service that we actually have some control over. That looks to be the web app. Let's start our stopwatch there and follow it across the catalog service before we finally get to the catalog DB. Cool, we have the service mapped out. Let's start talking about various latency thresholds for the catalog service. Here, we can codify what perfect and normal reliability targets look like for this service, which help us establish a baseline for further conversations, such as trying to figure out what unhappy and sad levels of service would be. To help us here, let's think about what actions we might want to take to remediate the service when it degrades. Here, it looks like the team wants to send a message on Slack and autoscale it if 95% of the writes to catalog DB exceed 4,000 milliseconds. And then if the service degrades even further, such that 99% of the writes exceed 4,500 milliseconds, roll back, declare an incident, and investigate it. These sound like pretty well-designed SLOs to me. For our next case study, let's talk about the more complex service architecture of Fortress Bank. Fortress Bank is a card processor that has strong contractual and regulatory incentives to ensure payments are made to individuals quickly. When we first met with Fortress Bank, this was their service architecture. You can see it's composed of many services talking to each other. After some discussion during discovery, it was identified that we needed to bifurcate this into distinct user journeys. In doing so, we ended up with 2 end-to-end SLOs that measured the various latency targets. Following a similar process as described earlier, we mapped out the flow and made it clear which services were in scope and which were out of scope. Due to contractual obligations, this first user journey had an SLA where 99% of the time an acknowledgement of payment had to be processed within 2000 milliseconds. We then asked to go back to the existing data to see how long the fastest 50th percentile transactions took. To our surprise, it was a lightning quick 100 milliseconds. With our fast and slow boundaries defined, we can now make steps up towards our SLA. It was decided that OK behavior could be defined when the 90th percentile takes 1000 milliseconds. And when that occurs, let's give the ops team a heads up and send them a Slack message. Going further, we also defined laggy behavior to be when the 95th percentile is at 1500 milliseconds. When that SLO is reached, they wanted to submit a formal ServiceNow ticket so that we start documenting the degradation of service. And finally, our last SLO before we get to our SLA, we defined this last SLO as when the 99th percentile hits 1700 milliseconds. Clearly, if this is occurring, something is wrong and we need to page on call. Moving on to designing SLOs for the second user journey, it's clear that this flow is much more complex. However, we can still follow the same pattern of codifying the reliability targets necessary for the SLA, examining the existing system behavior to see where the 50th percentile of the data lies, then work our way to the middle and set reasonable targets and actions to be taken. See, when you follow the SLODLC, even some complex architectures can still be broken down, instrumented, and measured to create meaningful and actionable SLOs. Our third case study is StormCloud. StormCloud is a low-code development platform that wanted to monitor the reliability of their customers' build environments. Due to the nature of these build environments, they were looking to design SLOs that fit an unknown and constantly changing architecture. To further complicate matters, they were also competing technology stacks with traditional and next-generation infrastructure. They needed an automated solution that could dynamically fit into their build pipelines to measure the reliability of their customers' environments at scale. They did so on the traditional infrastructure by adopting the OpenSLO spec, setting generic reliability targets, and adding additional actions to create, update, and destroy SLOs on demand as new environments are built and torn down. On the more modern parts of the infrastructure, they're able to utilize Terraform modules for configuring error rates and thresholds on both their SLOs that needed time slices and occurrences. They were able to dial in and set exactly what they needed on their infrastructure. At first, what seemed to be a daunting task, StormCloud was able to create two independent solutions to scale the implementation of their SLOs in a generic manner. Our final case study is Streams.rs. Streams.rs is in the entertainment industry where they provide streaming video globally. They needed SLOs to measure the latency of their streaming video service in order to exceed contractual obligations and to stay competitive with other streaming providers. After spending time discovering, designing, and implementing their SLOs, they started a cycle of reviewing their SLOs that they created. The SLO here is clearly underperforming. After analyzing, there were several one-off events that kept affecting their reliability targets. However, looking slowly at the SLI chart, we were able to diagnose an issue that was contributing to their reliability targets. Feel free to pause the video for a moment and try to identify it. Okay, here's the answer. After 24 hours, the cache would refresh at the same exact time and trigger a 30 to 40 minute spike in latency every day. When you review your SLOs, you could gain insight about your infrastructure and dependencies you didn't even know were affecting your user experience. And with that, I hope you enjoyed this talk and got a taste of what it's like to discover, design, implement, operate, and review service level objectives. If you'd like to learn more about the SLODLC, please check out our website, SLODLC.com. And if you like what you see there, please join our conversations and talk about it with us in our Slack channel. And if you have additional ideas on how the SLODLC can be improved, please visit our GitHub and help the community make it better. Thank you very much, and please enjoy the rest of SLOconf. Bye-bye now.